Now we will look at something called function notation. This is the notation that we will often use from here on out whenever we deal with functions. So if we have an equation that represents y as a function of x, then if that name of that function is f, we can write y equals f of x. So here, x is the input, f is applied to that input, and the output is y. So you might see individuals, when introducing the idea of a function, f is the name of the rule, and into that rule we're going to put in an x value, and out comes a y value. So some important remarks here. We read this as f of x. This does not mean f times x. It is f applied to x. So f gets applied to x and the output is y. We don't have to use just f either. We could have g of x, we could have h of x. The name of the function can vary. So now we have the concept of an argument of a function and the value of a function. So the argument is just that value that you're applying f to. And the value of the function is just simply the output. So if f of x equals 2x minus 1, x is the argument, 2x minus 1 is the value. Now suppose we want to know the y value when x is 7. What we can do is we can replace x with 7, and if we do that here, we do that here as well. Everywhere we see x gets replaced with 7. So instead of f of x equals 2x minus 1, we get f of 7 equals 2 times 7 minus 1. But 2 times 7 is 14, and so we get 13. Now a few comments about this. Notice, I don't have to write f of 7 equals, f of 7 equals, f of 7 equals. I can write in a column, and I can simply write equals, which is like a train track that goes back to the original. So what's f of 7 equal? It's equal to this, which is equal to this, which is equal to this. The equal signs are important because they lead us to 13. Now, going back to the concept of an argument of a function and the value of a function, 7 is the value to which we are applying f, so 7 is the argument. 13 is the value of the function at that argument. So let's take a look at f of x equals x squared plus 4x minus 3, and we are going to evaluate that function at various x values. So let's look at f of 3. So f of 3 will equal 3 squared plus 4 times 3 minus 3. So notice everywhere we put in 3 for x. Now, what is 3 squared? It's 9. Plus 12, then, minus 3. And this is simply equal to 18. Now, I want you to try this next one on your own. f of negative 4 equals what? Show all your work. Go ahead and pause the video and see what you obtain. So the first thing that we need to do is notice that if we're substituting in a value for x, the very first thing that happens is that x value gets squared. So we need to make a determination. What is getting squared initially? If f is getting applied to negative 4, then we need to square that negative 4. So the question is, do we want to write negative 4 squared, or do we want to write the square of negative 4? Because these are not the same. The square of negative 4, the second one, is negative 4 times negative 4, which is positive 16. The first one, negative 4 squared, is actually the square of 4 made negative. So this one would be negative 16. In this situation, we are squaring x. And so we need to square negative 4, which means that we are going to be squaring negative 4 as in the second. So we're going to square negative 4. The parentheses are very important. Plus 4 times negative 4 minus 3. So the square of negative 4 is positive 16. Then 4 times negative 4 gives us negative 16 minus 3. And this yields for us negative 3. Now let's look at part C, f of negative x. So as in before, we want to square negative x. So we need parentheses. Squaring negative x plus 4 times negative x minus 3. Now squaring negative x, that will be negative x times negative x. So this yields positive x squared, then minus 4x minus 3. And that's it. Now let's look at part D, f of x plus h. So everywhere we see x, we will replace with x plus h. So we're going to square plus 4 times that minus 3. So we will replace x with x plus h. So now squaring x plus h. That's x plus h times x plus h, which is something that we need to FOIL. So we'll have x squared plus xh plus xh plus h squared. That means that x plus h quantity squared is x squared plus 2xh plus h squared. Then we can distribute the 4. So plus 4x plus 4h minus 3. And that's our answer. Nothing is like, so we can combine no like terms. It's simplified. Now let's take a look at this function. G of x equals, and we have a fraction. So we want to, in this first example, substitute in x plus 1 everywhere we see x. So we see x here, we see x here, we see x here. Everywhere we'll get x plus 1 instead. So this will equal 2 times x plus 1 minus 1 all over 3 times that quantity plus 4. Now we simplify. In the numerator, we will distribute the 2. We get 2x plus 2, then subtract 1. Then we can distribute the 3 in the denominator. We have 3x plus 3 plus 4. Collect like terms. We have 2x plus 1. And in the denominator, we have 3x plus 7. And that's our answer. Now this is very similar to what we just did. Instead of having x plus 1, we have x plus h. So in the same way, everywhere we saw x, we'll replace with x plus h. Go ahead and try this one on your own. Pause the video and see how you fare. So we have 2 times our input over, 2 times our input minus 1, 3 times our input plus 4. So everywhere we see x, we will replace with our input x plus h. Now we distribute and simplify. 2x plus 2h minus 1 all over 3x plus 3h plus 4. Notice There are no like terms, so we cannot collect any like terms. Likewise in the denominator. And so we are finished.